Testing 1, 2, 3.
Like a whole sentence.
Hi, I'm Bob Novak. I'd like to tell you my life story. Hi, I'm Bob Novak, founder and president of Novak Electronics. A lot of people have asked me how I got into this industry, and it all started back when I was around 5 years old. I started building model airplanes, rubber band powered airplanes, and I got hooked on those really quick and continued doing that through high school, and in 1957 flew my very first RC airplane. And that really got me hooked onto things. So when I graduated high school, I knew I wanted to get into the radio control industry as such. So I went to college and I graduated as an electronics engineer, and sent my resumes out to all the existing RC manufacturers in this country, and literally none of them answered my hopes of going to work for them. So I had to get a real job. And at that job, I happened to be working for a company that made the quartz crystals for all the RC manufacturers. So one day one of the guys came by on their way to the Toledo show in Toledo, Ohio, which is a big trade show that's still in existence today, and they stopped by our plant and they had a problem with some of their crystals, so my boss told me to solve their problem, and I did that. And the company happened to be Microavionics. And the gentleman of that company was the guy that invented the digital pulse radio systems that we all use today. He hired me and moved me from Illinois to California, and that's when I first started working in the RC industry. All of our radios, of course, were for model airplanes at the time, and I worked for that company for 3 years until it got bought out, and I was laid off, and I decided to start my own company. In 1978, we started Novak Electronics in my garage. I was the sole owner and employee, and we were making airborne equipment for model airplane pylon racers, which were 200-mile-an-hour airplanes. And the servo that we had was extremely fast, and they worked very well in those airplanes. It turned out that one of the drivers back east, who was running 12-scale electrics, happened to be an airplane guy, and he tried one of our servos in one of the cars, and they found out that the speed really worked well. So that started our foray into the electric car business. We started having to make so many servos for the electric car stuff, we dropped our airplane stuff. I got so busy that I had to expand the company, and so I had two very pretty daughters who were in high school, and I taught them how to solder, and they both made money making servo amplifiers for me, and they actually both made enough money to both of them could buy a car when they were able to drive. Then we decided to move into, that was, by the way, in my house that we were working on this stuff, and we decided to move into a building, and we moved into a building in Santa Ana, and we continued to grow, and we got bigger and bigger, and things progressed very nicely, and we started improving. We designed servos, different servos, receivers, and then we got into the electronic speed control business. In 1985, Siemens Electronics had a seminar on power MOSFETs, which I went to, and found out that these power MOSFETs would make an ideal electronic speed control. And I had figured out that the servo-based variable resistor just wasn't handling the power of the motors that we were having at that time. So we needed an electronic device to control the speed of the motors, of the brushed motors. So I designed the first power MOSFET ESC in 1985, and we started building that. The very first one was called the NESC1 and the NESC2, and then we had the NESC4, I believe, and then the biggest one we had was the T4. That was the TempFit series of Siemens MOSFETs. That came on a couple of years later. And probably the T4 speed control was one of our most popular speed controls that we probably have ever made. In 1989, we developed the ESC called the 828. It was a microprocessor-based speed control, which allowed us to do many, many things that the existing circuitry that we used on our first ESC wouldn't allow us to do. And after that, the things that came along were the one touch of the microprocessor. We also developed the first programmable ESC called the Cyclone in 1996. Also later that year, we developed what we called the data link to complement the Cyclone speed control. And the data link was a device to hook the speed control to a computer, so you could use the computer to change the parameters of the speed control. And later that year, we also developed what we called the Pit Wizard, which was a handheld device to do a similar thing that the computer did, but it would be a device you could take to the racetrack, download programs on it, and then transfer those programs to the speed controls. And that made that very popular. During the following years, we could see that the brush motors were pretty much coming to the end of their performance life, to speak. So we took upon ourselves to design brushless motors for the model cars. And we came out with the very first sensor-based brushless motor and our sensor-based brushless speed control. Now the reason we went with sensored instead of sensorless controllers and motors like the airplane people use is we needed maximum torque at 0 RPM in model cars to accelerate, which the airplanes didn't use. We announced this at the 2002 Chicago show, and then we shipped our first brushless motor and speed control in 2003. And we think that this really revolutionized model car racing for years and years to come. It set the stage for increased performance with very, very little maintenance and tremendous amount of flexibility. Since the introduction of the brushless motor and speed controls, we have made great strides in development and designing of new speed controls that apply to different parts of our industry, different cost parts of this industry, and we've made some strides in new technology that we're very, very proud of. Since we are able to do all of this here in this facility, which I'd like to mention is we make everything here. This is U.S. Products made here in the United States, and we do all the design work here, from actual electronic design to writing code to doing our advertisement, everything that you can think of that needs to be done. We do it here in this factory. It's a family-run business. I've got my 2 daughters, 1 son-in-law work for us here, and we have very, very many very competent people and employees that have been with us for a very long time. My thoughts on the state of the industry as we move forward is very positive. I think that our industry has expanded tremendously over the last, since I get into it in the industry, in the hobby, 55 years I've been in it. It's come from a very, very young industry to a very, very mature, very technology-oriented industry, and I really think that we can come up with more new products in the future, which will be exciting, and I think that the whole industry is going to grow very, very well.